All right, so hi, I'm over here in the middle of the page. If you want to know how to work these problems with the TI-84, maybe you don't like the table of values and kind of looking those things up is annoying to you, the TI-83, 84 can do this. So I'm going to walk through these directions with you. So here's a problem for us to work on. Consider the weights of 18-month-old boys in the United States. According to the published growth charts, the average weight is approximately 11.8 kilograms, the standard deviation of 1.28 kilograms. Calculate the percent, or if this is the normal distribution, calculate how many 18-month-old boys in the U.S. could weigh between 10.5 and 14.4 kilograms. So I hope when you hear average and you see a standard deviation and you hear normally distributed, you start thinking about this normal curve. And when they give you a range, a between situation, with the 10.5 and the 14.4, you might start thinking about, okay, what would it look like to kind of set up both of these z-scores and figure out the area under this normal distribution between those two values, okay? So drawing a picture always helps, right? I love drawing pictures. So they put the mean here in the middle. They put a mark where both kind of ranges are. They've got their standard deviation to space this out. And they want to know this area in blue. Now, they did not take their story out of context. Remember yesterday I talked about how you have to transfer your mean and standard deviation from your story into the standard normal curve in order to use z-scores. That is still true. If you're going to use z-scores in the table, you need to transfer this information over. So they should have a mean of 0, a standard deviation of 1, 2, and 3 on both sides. And they should use the little formula to take their numbers 10.5 and 14.4 and convert them into z-score language. But the lucky part of using a calculator is that you don't have to do that. The calculator can work this problem for us without having to use z-scores. Kind of crazy. Okay, so that's all just the story. Let's go to the calculator here and let's find kind of what we need to do. We're going to have to tell the calculator a lot of information, but it's all located under this. Hopefully you can see my calculator over here. It's all located under this blue distribution thing, right? Like the normal distribution. So we're going to go to the blue button and we're going to press VARS so that we access the distribution menu. You are going to use the normal CDF function. Do not ever use normal PDF. Use normal CDF, okay? So choice number 2, I'm going to press enter, and let's talk about what's happening. The calculator wants a lower and an upper boundary for your area. What's the smallest number that you want? What's the highest number that you want to find the area between? If you wanted all the area to the left, you could use a really, really tiny number for your lower boundary. That's what they're doing right here. -1 E99 is this really tiny number. We, in our story, we had, I believe it was 10.4 for the kids' smaller end of the weight. Oh, sorry, 10.5. That is the lower boundary of what I need, right, for this blue area here. The upper boundary of the blue area, so we're setting our limits, our boundaries, is 14.4. So I'm going to go to the next section, 14.4. What's the mean for my data set? 0 and 1 are sometimes what your mean are, but here we have a mean of 11.8 and we have a standard deviation of 1.28. The calculator is so nice. You don't have to convert everything over to the normal distribution where the mean is 0 and the standard deviations are 1, 2, and 3. You can directly put in the mean that you have in your context in your story and the standard deviation you have in your context in your story. And we're set up here. We're going to press paste. We want to enter this data and we're going to press enter one more time. What it's telling me right now, this 0.8239 is my final answer. That is how much area or how many boys are between there and there. Yeah, 82.4 if we round percent. Isn't that awesome? We love the calculator. That's the percent of boys that fall, 18-month-old boys that fall between those two boundaries.